up until this point, we've been calculating percentages and probability. Now we're going to look at chapter 18, which is how confident we are that probability will happen. So confident intervals for proportions, which is what the confusion was yesterday because I was looking at means. All right. So we have, of course, two types of confidence interval formulas. But the basic formula is your estimate plus or minus the margin of error. For this chapter, we're going to look at proportions, so categorical data. We're going to have our P or P hat, that's going to be our estimate, so our proportion, plus or minus Z, so our Z-score, times, what is this? Square root of PQ over N. Standard deviation, very good. So plus or minus Z times our standard deviation. Now the other one, the one I was doing yesterday, is means, or quantitative data, is the mean, or average, plus or minus Z over that standard deviation. But for chapter 18, we're going to focus on this one right here. So what is confidence interval? So we have a range of values. My P is going to be my point estimate, and my margin of error is, this value right here is going to be plus or minus the distance. Now we can range, do I want 90% confidence, or 95% confidence, or maybe just 10% confidence, or 99.7% confidence? Those can change. So here's our basic formula that we're going to focus on today. In April 2011, Yale George Mason poll of 1,010 USA adults asking questions about certain topics reported a margin error of 3%. It is convention among pollsters to use a 95% confidence level and report the worst case margin error based on P equals 0.5. How did the researchers calculate their margin of error? Again, margin of error is, I have some estimate here. It's going to be my plus and minus from that point estimate. That is my margin of error. This is going to be a very handy table for you to use. Notice it gives you your Z-score pertaining to your confidence interval. So if I'm looking at a confidence interval of 95%, then I want to look at the Z-score of 1.96. You'll also, with here you'll probably see 2. That's because we're actually 2 standard deviations. So this will be the more exact, but you can also, if you're trying to research this on yourself, you'll see other people using 2 here. But we'll use 1.96. We'll use the actual Z-score. So, which one of these are we going to use? Proportions or means? Which of these do I want to use to calculate my margin of error? Technically, this kind of gives it away. P, which P ends up with proportions, right? So we're not going to focus on the means. Like I said, chapter 18 is talking about the margin of error for proportions. So let's plug it into our formula. Z times, so what is my Z-score that I'm going to use? 1.96, because I want a 95% confidence. So Z times the square root of what's going to be my P value? 0.5 gives that for us. What's going to be my Q value? 0.5, so it's P minus 1. And what is N? What is N in this problem?
1,010.
Very good. N is right here. 1,010. So to find my margin of error, I need to take 1.96, multiply that to the square root of 0.5 times 0.5 over 1,010. And I get 0.0308. Or I guess we could say 0.031. That is my margin of error. So I'm going a distance of plus and minus from my estimate this far. So that's my, standing here on the estimate, I'm going plus and minus 0.31, my margin of error. Like so. So to translate this, for 95% confidence level, their margin of error is just over 3%. So how confident are you that you can get your data? Well, with 95% confidence, I can get that 3% error. Now let's look at the confidence interval. So let's put it all together now that we figured out how to calculate margin of error. In October 2010, the Gallup asked 510 randomly sampled adults the question: generally speaking, do you believe the death penalty is applied fairly or unfairly in this country today? Of these, 58% answered fairly. From this survey, what can we conclude about the opinions of all adults? First, we need to figure out if this fits with our normal model. So, is it randomized?
Yes.
It is, right? It told me so. Randomly sampled, right? So let's randomize. Do I fit the 10% condition? Am I under 10% of the population? Would you say 510 is less than 10% of the population? I would say so, right? Since we're pulling, I guess, the total population of the country, that's a lot less than 10%. And success failure. How can I calculate this? Remember success failure? What am I looking at?
The NP.
NP. So what is my N value?
510.
510. What is my P value? 58, so 0.58. And I want that number to be, well, let's figure out what it equals. 510 times 0.58, 295, and I need this number to be what? Greater than or equal to?
10.
Very good, 10. That's my success. What about my failure?
Q.
Q, yeah, so in Q, what's the Q value?
42.
0.42, thank you. And that equals 214.4, and that needs to be greater than or equal to 10. So I'm good there. So I'm good to represent this as a normal model. Now, let's see. We want to include, does it give us a confidence interval we want to use? No? Okay. Let's see. What are we going to use? Let's use 95%. So I want a confidence level of 95%. So let's find our confidence interval. So my estimate, what do we think our estimate is going to be here? What do we want to use as our estimate? Notice we're talking about proportions, so my estimate is going to be P. What's our P value?
58.
50.58. So again, estimate is going to be your P value with proportions, or P hat. So P is going to be 0.58, and I want a plus minus margin of error. Now I need to calculate that. So ME equals, what was that formula? Z. So what value am I going to use for Z for this problem if I want 95% confidence? 1.96 times the square root of, should be used to this by now, standard deviation, so P times Q over N. So let's see, 0.58 times 0.42 all over 510. Somebody real quick, what is our margin of error? Somebody double check with me. I got 0.04, we'll call it 3. 0.043. Who can confirm or deny that? Are we going with 0.043? Okay. So I have an estimate of 0.58 with a margin of error plus or minus 0.043. And I'm 95% confident that I can get all that within that range. Another way to write margin of error, confidence interval. So here's one way. So your estimate plus margin of error. Another way is to give the range or the domain. And you would write that in what's called, if you remember from math, interval notation. So it's going from my, oops, let me erase that. Lowest value to highest value. So I would take 0.58 and subtract 0.043. I get 0.537. Then I would take 0.58 and add 0.043. And I get 0.623. Just another way to represent the confidence interval. See where I got these numbers. Took this, subtracted it, took this, and added it. So I'm 95% confident that I'll fall within these two. If I want to be 99.9% confident, then that would change to 3.291. Let's look at something real quick. Actually, so how to translate this? I am 95% confident that between 53.7% and 62.3% of all U.S. adults think that the death penalty is applied fairly. Makes sense? So I'm 95% confident that between these two results, oops, where's my cursor? Come up there, oh there. The U.S. adults will think the death penalty is fair. Where's my calculator? So if you're seeing how I'm doing margin of error, I'm trying to do it all in one. So I'm going the confidence interval of 1.96 0.96, multiply that to the square root. And then inside of here we have a fraction, so alpha y equals, put a fraction, put in my top part, so 1.8 times 0.42 over 510. That's how I found my confidence interval. Now, what can you tell me? What if I were to increase this to 51,000? What does that do with my margin of error? So I increased my sample size. I increased my n. What did that do to the margin of error?
It made it smaller.
Made it smaller, right? Made it smaller. The more samples I get, the more confident I can have. And the smaller that confidence interval becomes. Something to note. I think that's all I want to say about that. FYI, the calculator has a feature to do the confidence interval. Even though the calculation isn't that complicated, you can easily do it by hand. If you feel like you need your confidence in the calculator, here's how you can pull this off. So stat, test. Go all the way to test. And go all the way down to A. So I want 1 proportion Z interval. This one right here. 1 proportion Z interval. Hit enter. Now very important. X and N have to be whole numbers. Watch what happens if I put a decimal. Doesn't like it. Doesn't like decimals. So let's see, stats, again, let's see, quit, stats, test, all the way down to A, enter. These have to be whole numbers. I have to fill something in there for us. Right. What would be my x value in this problem? Don't want to give it away. Maybe I did already. What would be my x value? Notice my n value that I'm going to plug in is 510. Where am I going to get my x?
296.
X will be
10 times
my point estimate right here. If I think 58% answer fairly, what's 58% of 510? Yeah. So to find this x, you're going to take your rough estimate, right? So 510 times 0.58 will be 296. So go into my calculator for x, 296. My n value was what, 510?
Yeah.
And you can put in your confidence interval. We wanted what, 95%? So 0.95 and calculate. And notice how it gives you the range. I'm going from 0.53 or 0.54 to 0.62. And that's what we got, right? 0.537, 0.62. I guess technically you can run up to 8, but we know the calculator does have limitations. But it's a good tool to spot check. So our calculator can calculate our intervals for us. Very nice. Margin of error, though, you have to do this by hand. So you have to know it's z times your standard deviation. Here's an interesting problem. The Yale George Mason poll that estimated that 40% of all voters believe the scientists disagree about whether global warming exists had a margin of error of plus or minus 3%. Suppose an environmental group planned a follow-up survey of voters' opinions on global warming wants to determine that a 95% confidence interval with a margin of error of no more than 2%. How large of a sample size do you need? So which one of these variables am I trying to solve for? If I'm trying to find the sample, how large the sample is. Am I solving for the margin error? Am I solving for z, p, q, or n? So notice now I need to find n. So let's see if we're given enough information to solve this. So what would be my ME? What would be my ME?
Plus or minus 3%.
3? Or looks like a different group wants what?
Oh, no more.
No more than 2%. So my ME is going to equal 0.02. Make sense? That's what they want their margin of error to be. So I'm plugging in 0.02 for ME. That equals, do I have a z value?
Yeah.
Yeah. At 95%, I have that value, 1.96. And I'm multiplying that to the square root of, what's p?
40?
0.4. So what's q? 0.6. And we're trying to find n. Well, looks like I have enough information. I just need to start doing some math. Solve for n. So what would you do first? We need to move everything over to the other side. So tell me, how would you solve this?
Divide one by 90.
Yeah, let's divide by that z value, right? You get 0.0102 What would you do next? Yeah, I need to get rid of the square root, right? So how do you get rid of a square? Roots. What's the opposite? Squaring. So take that number and square it. So let's see here, put in my answer and square it. Let me just make sure I did that right. Oh, forgot the square. Okay, so I got 1.0412 to the power of -4. That equals that. Now what? I mean, I guess we could go ahead and multiply these two together. I get 0.24. So I have 1.041 to the power of 10 times the -4 equals 0.24 over n. How would you solve for n? Well, I know if what's the opposite of divided? Multiply by n. N would come over here, right? So this would be multiplied by n, which leaves this side with 0.24. So what would I do to get rid of this from n? Since it's being multiplied. Divide. So I would take 0.24 and divide it by that 1.041 e to the -4. And I get, since we are talking about people, you might want to round. I get about 2,305, or I need about 2,305 respondents to get a margin error of 2%. Who's this? Oh, that's not you. If you want an exact formula, let me go ahead and calculate that for you. Z squared, and then divide by PQ. Or something, no, it's PQ on top. Sorry. Let me give myself some room. So for solving for n, let's create a formula for n. So n equals, let's see, I have m(e), my margin error, divided by z, because I'm dividing that here. Now I need to get rid of that square root, so I'm squaring this, and then multiply, and then divide. PQ. So that would be your formula to find n, if you need to. N equals P times Q over ME over Z squared. Which is what we did here. P times Q over ME over Z squared. Yep. All right.